Welcome back to the last of the Redox predicting reactions and balancing reactions mimeos. We are looking at the AP style of predicting, and let's read and capture some keywords first. It says acidified. That's a great hint that we are dealing with a redox reaction. It's acidified with sulfuric acid, and there will be a temptation to include this in the balanced reaction, but we're not going to be looking at that. Our primary players are the potassium permanganate and the sodium bromide. Now, since we have solutions of these and we're dealing with redox, I can ignore the group 1 ions because they will not be reduced in the presence of water. So I can focus on my permanganate and my bromide. Now, since it is an acidified solution, you need to memorize that permanganate reduces to the manganese plus 2 ion. And since that's a reduction, that means the bromide's an oxidation, and that's going to go to diatomic bromine. Let's put in our oxidation numbers so we can balance the electrons. Now, manganese became more negative. That means manganese was reduced in this case, and it was reduced by gaining 5 electrons. Our bromide went to bromine, and I like to do with this with diatomics at least 2. Could be more, but it has to be at least 2 were oxidized. And so we have a loss of 2 electrons or more. Now we can balance those electrons. The lowest whole number ratio between 5 and 10, 2 is 10. So I'm going to multiply that by 2 and this by 5. So I would have a 2 and a 10 and a 2 and a 5. Now I need to balance my elements. We balance electrons, charge, and elements. I have 8 oxygens on my reactant side. I have 0 oxygens on my product side. Since it's an acidic solution, I balance oxygens with an equal number of waters. So I'm deficient 8, so I'm going to add 8 waters. And then there's plenty H plus around in an acidified solution, and I'll balance my hydrogens by adding 16 H plus. So now we have our net ionic equation, and I encourage you to take a look at some of the color changes that go on in this, because you know AP loves for you to know those color changes. For now, we're going to go on and help.